What is the ratio of longest wavelengths corresponding to Lyman and Balmer series in hydrogen spectrum? The longest wavelength in any series of the hydrogen spectrum corresponds to transition between the lowest energy levels in that series. The Lyman series corresponds to transitions ending at n is equal to 1 and the longest wavelength occurs for the transition n2 is equal to 2 to n1 equals 1. Thus, the wavelength is given by the Rydberg formula 1 by lambda is equal to RH into 1 by n1 square minus 1 by n2 square, where RH is Rydberg constant and for n1 is equal to 1 and n2 is equal to 2, we have 1 by lambda Lyman is equal to RH into 1 by 1 square minus 1 by 2 square. On solving, we get lambda Lyman is equal to 4 by 3 RH. The Balmer series corresponds to transitions ending at n1 is equal to 2 and the longest wavelength occurs for the transition n2 equals 3 to n1 equals 2. Again, by using Rydberg formula, we get 1 by lambda Balmer is equal to RH into 1 by 2 square minus 1 by 3 square. So on solving, we get 1 by lambda Balmer is equal to 5 by 36 RH and the reciprocal of which is lambda Balmer is equal to 36 by 5 RH. The ratio of longest wavelengths is given by longest wavelength in Lyman series by longest wavelength in Balmer series, which is nothing but lambda Lyman by lambda Balmer is equal to 4 by 3 RH divided by 36 by 5 RH. On simplifying, we get 20 by 108, which is nothing but 5 by 27. So the correct answer is option D, 5 by 27.